Hi everyone! It's time to go over this week's math review. So if you've got it done, you can check your answers with this video. If not, and you maybe need a little bit of help, you can watch it. Just make sure that you try it first before you just give up and copy the answers, because then you're not really learning anything or practicing. And then I'm going to post this. I'm going to have the lines and angles video up with this post so that you guys can watch that again and get some of those terms. You can always be practicing lines and angles on Zearn and on Seesaw. So if you haven't signed up for Seesaw yet, I would highly suggest doing so. It's a really cool website. Mrs. Shields made an awesome video about how to get on there. But for now, we're just going to focus on this math review. So enjoy! Number 21 on the review looks like this. This is the first problem you should see. It gives you 3 circles, all 3 split into 3 sections, but these 2 have all of them colored. If they all have it colored, it's equal to 1 whole. So if this is 1 whole, that means this is our second whole. And then over here, I'm going to have a fraction because only 1 part is represented out of 3. So I'm going to have 1/3. So one way to represent this fraction, because we have to represent it in 2 ways, is as 2 1/3. But we could also count all the sections that are colored in and put that number over 3. So we can have 2 1/3, or 1, 2, 3, 4, 5, 6, 7 over 3. So that's the 2 ways we can show that fraction. Question 22. 5 times 3/4. This looks a little bit different than the mixed numbers. This does not mean the same thing as 5 3/4. So before we were converting fractions in one way, and now we have to keep our denominator the same. So whatever number we get has to be over 4. So that only leaves 2 things to multiply. So it leaves 5 times 3. We know 5 times 3 should be 15. I can check my work by drawing a picture. If I make 5 circles and split them into 4 parts, and I color in 3 parts of each circle, I would have 3, 6, 9, 12, 15. So I've checked my work. 5 different groups of 3/4 gives me 15 fourths. Okay, so 23 talks about having 36 students in a class, and 1/4 of the students play a wind instrument. So we could do this a couple ways. 1/4 of the students would be splitting it into 4 groups and counting the amount that are in each group. So we could draw a picture, but I'm going to do it the quicker way, which would be dividing 36 by 4. So if we don't know how to do that right away, we can always go back to our long division. 36 on the inside, 4 on the outside. 4 fits into 3, 0 times. 0 times 4 is 0. And I have 36. How many times does 4 fit into 36? I can count by 4s to know that that is 9 times. 9 times 4 is 36. 36 minus 36 is 0. So 9 students play a wind instrument. Okay, make sure you have your sentence in there so we know what you're talking about. At least have a label. Otherwise, we may think we're talking about 9 cheeseburgers or cats or dogs. We haven't talked much about decimals, if any at all. It was coming, I promise, but we have to adapt. So it starts us with 6/10. It wants us to write it as a decimal. So we have to, when we think about decimals, I think the easiest way is to make the whole number 6 with our decimal point, then a 0. Because the 0 is just kind of a placeholder right now. So what we have to do is anytime we have the 10 in the denominator and we're making it a decimal, we move our decimal point to the left 1 space. So now it should appear as if it is decimal with our 6. And you can ditch the 0, or you can keep it because it doesn't mean anything. So now we have 0.6, okay, which is 6/10, just written as a decimal, because fractions and decimals go hand in hand. So we have 0.6. Had it have been 6/100, this would have looked a little bit different. Okay, we would have started with our 6.0. But instead of moving it just 1 for the 10, we'd have to move it 2 times. You move it for the amount of zeros there are in the denominator. So I'd move it 1, 2. So it looks kind of silly that way to have this blank space. So guess what we're going to put? A 0. Now we have what looks like decimal 0.6, which is 6/100. All right, now we have to write 57/100 as a fraction. So the way decimals work is this would be our ones place. This is our tenths with a TH. This is our hundredths. We'd have a thousandths and so on. So right now we're showing 57/100. So if we think about it, if we're using a fraction to equal 57/100, we can hear 100 in the name. There's 2 zeros and 2 spaces represented after the decimal point. So we could put a 57 on top because we have our 57, and it goes clear out to the hundredths, which makes our denominator. Let's talk about ordering decimals from least to greatest in problem 26. So we have a 7. I'm going to change it to 7.0 so that everything kind of looks the same. So the least number goes all the way to the left. We've talked about that. And the greatest goes all the way to the right. I'm going to start with what I know is greatest, which is 7. And I'm going to put my 7 all the way to the right. So I can cross that one off. I'm done with it. So really, I can look at the whole number part first and decide what's going to be least or greatest. So I've got 0, 3, 1, and another 3. And out of those, I know that 0 is the least. So 0.5 is my smallest number, followed by 1.5 because 1 is the next smallest number. But now I'm in a predicament. I have 3.9 and 3.2. And I have 2 spots left, and they both start with 3. I don't think I should just pick a random place to put them. So now I have to look and see which decimal number is greater. I have a 2 or I have a 9. So I'm going to put my 3.2 here and my 3.9 at my 7. 3.9 is almost 4, so I know that that one is going to be much greater than 3.2, which if I rounded it to the whole number would only be 3. Question 27 wants us to use less than, greater than, or equal to compare 0.70 and 0.75. So the easiest way I think to do this is to cover the decimal. Which number is greater, 70 or 75? We know it's 75, so 0.75 is greater than 0.70. We can also look at the last place we see, 5 and 0. 5 is greater than the 0, so 0.70 is less than 0.75. 28 says 24 inches equals blank feet. I don't mean your actual feet you walk on. I mean the type of foot that you measure with. So we have to look at, there's 12 inches on a ruler. We should know that from science and measurement. 1 ruler is equal to 1 foot. Okay, so really this turns into a problem of 12 times something has to equal 24. We could take the time to guess and check, but we should know that it is 12 times 2 equaling 24. So 24 inches, okay, equals 2 feet. If I put two rulers together, I had 12 inches on each. Put them together, I'd have 24 inches long. Okay, number 29 asks about how many ounces are in 16 pounds. But I need to know first, how many ounces are in a pound? I don't know. I have my balance scale, and I have a 1 pound weight, and I have two 8-ounce weights, and I'm thinking that maybe two of these kind of feels the same, but I can't really tell for sure, so we're going to try and use the pan balance. So here we go. This side is going to have the 1 pound weight, and it completely takes it to the table. This side is going to get both of the 8-ounce, and if I've got two 8-ounce, that would be 16 ounces I'm trying to balance out with 1 pound. So I'm going to let it kind of settle itself here. Help it out a little bit. Not pushing it one way or the other. Okay, my arrow matches this arrow, which means that there are 16 ounces in 1 pound. So, 16 ounces in a pound. And I need to know how many ounces are in 16 pounds. Ounces is OZ as a abbreviation. So if I have 16 ounces per pound in 1 pound, I should have 16 times 16. So we're going to do a little double-digit division with the turtle collar and his eggs. Okay, so 6 times 6, we know is my favorite math fact, is 36. 6 times 1 is 6, plus 3 more is 9, okay? I've got my turtle head. I've done the eye and the neck and the ear and the neck. You can get rid of this and slap a collar on him, and he drops his egg. Now I have to do 1 times 6, which is 6, and 1 times 1, which is 1. And I add these two things together to get my answer. 6 plus 0 is 6. 9 plus 6 is 15, and I carry my 1. 1 plus 1 is 2. So 256 ounces in 16 pounds. Okay, now we have Ellen, who's leaving for a party at 8:30. The party ends an hour and 15 minutes after the time she leaves. What time does she need to leave the party? So to find out what time that party ends, we could start by using the clock at 8:30. And if we take it an hour, it has to make 1 full rotation. So I'm going to make the clock make 1 full rotation. And it ends at 9:30. Okay? So 1 hour gets me to 9:30. Okay? But I still have to add 15 minutes in. We know that each sector of the clock, so this 1, 2, 3, that's 15 minutes, 4, 5, 6, another 15 minutes, 7, 8, 9 is another 15, 10, 11, 12 is another 15. So I'm at an even 15 number right now. I'm at 30. If I add 5 minutes, 10 minutes, 15 minutes, that makes it so that the hour hand is right in between the 9 and the 10. It still means it's 9. 9. We don't say 9:09. We say 9:45. So the party ends at 9:45. We have Farmer Brown. He is putting a fence around his garden, and he has one side that's 16 feet. The other side is 20 feet. Okay. We want to know how much fence he needs to surround his garden, not just to do this side and this side. We need to know how much fence he needs to go all the way around. I don't know these two legs, Miss Wilson. What do I do? Easy. This side and this side should be equal to each other, right? Because rectangles have two pairs of sides that are parallel to one another. that are the same length. So the 16 and the 16 are on the sides, and these two are the same. If I want to know how much is going to go all the way around, that to me sounds a little bit like perimeter, which is side plus side plus side plus side. So it looks like what I need to do is this: 20 plus 20 plus 16 plus 16. 20 plus 20, I know right away is 40, plus 16 plus 16, which is 32. So now I have 40 plus 32, which will give me 72 feet of fence. Make sure you give it a label, if not a sentence. Otherwise, I could think you're going to have 72 feet of rope or yarn. Okay, you have to be specific. Feet of fence. All right, 32. It tells us that Carter is making a sign and he needs to paint it. We need to know the area of the sign so he knows how much paint to buy. It tells us right there area. I know right away that area equals length times width. So my length is 24, my width is 12. So my area, which is the number we don't know yet, we're going to be able to find it by multiplying 24 times 12. So I've got my turtle. I need to do the neck times the ear. 2 times 4 is 8. And the neck times the eye. 2 times 2 is 4. Put a collar on our turtle and he drops an egg. 1 times 4 is 4. 1 times 2 is 2. And now I have to add. 8 plus 0 is 8. 4 plus 4 is 8. 0 plus 2 is 2. Don't forget, the label for area always has to have square units, and this time it was inches. So his sign is 288 square inches. All right, I want to do 33 and 34 together because they kind of mean the same thing. I know we don't have protractors at home. That's okay. So 33 wants us to figure out with a protractor about how big this angle is. So the solid black line is where my angle is. And it looks like it's a right angle from the perspective that you look at it. But the right angle is where the dotted line would be. And they definitely don't match up. So I know this is an acute angle. It's got to be really close to 90 degrees. So a good guess for about how many degrees this is not like 10. I'd say it's somewhere in like the 75 to 89 range. Okay, so anywhere in between there would be a solid guess. Okay, now as far as this one goes, 130 degree angle. I know it can't be acute because 89 is way less than 130. It can't be right because that's only a 90 degree angle, and 90 and 130 are not equal to each other. But it needs to be somewhere in between this obtuse range because the lowest part of the obtuse angles is 91 degrees, and the largest measure it could be is 179. So I'm going to start with a straight ray for the first part of my angle, and I'm going to draw it like this. That to me seems like it would be about 130 degrees. Okay, so I know we don't have protractors. I understand that. I just want you guys to try and make a reasonable guess because saying this would be drawn like this, absolutely not okay because that's definitely an acute angle. Okay, we know what all these look like by now. There's lots of different things you can look at on Google Classroom to refresh us of that. So if you still have questions about this, check out some of the Seesaw lessons I have or some of the other math problems that are out there, maybe on Zearn, okay, because I've set you all to angles and measures. So you guys should have lots of opportunities to practice this through those programs. All right, let's take a look at number 35. So this kind of gets at an idea that we were trying to kind of get to when we were playing Kahoot that day with the lines and angles, where we had a 90 degree angle or a 180 degree angle, and they gave us part. So those are called the complementary and supplementary angles. So right now, our biggest measure can be 90, okay, because it is a right angle. Right angles equal 90. And I know I have one part of the angle that is 30 degrees, but I need to figure out this x piece, okay? I know it has to be bigger than 30 because you can visually look at it and see that that section is bigger, but it can't be bigger than 90 because 90 is the maximum measure of this whole angle. So really what we're doing is we're splitting it into two parts that can add together to get to 90. But I'm going to do the backwards version of it. I'm going to subtract. Okay, so I'm going to start with 90 out here. And I'm going to subtract a number that I know. I know I have 30 degrees. Okay, so 90 degrees minus 30 degrees. If I subtract 30 from 90, I could even do 9 minus 3, put a 0 on the end. That should be 60 degrees. Well, where in the world does that go? Okay, we have to think. It's not the whole measure. The whole measure is 90 degrees. This part's 30, so 30 plus x. Okay, x is equal to 60 degrees. 60 plus 30 is 90. Okay, kind of on that same track of thought. This time I've got a whole straight line. We know straight lines are 180 degrees. Okay, so I've got 110 showing. Okay, if I add those two things together, the whole side over here is 110 degrees. How am I going to figure out what x is? Okay, think about it. If I do 180 degrees and I subtract the 110 that I already have showing up here, 180 minus 110 is 70 degrees. So this right here should equal 70 degrees. Okay, and if we added 70 plus 100 plus 10, we would get the whole angle measure of 180 degrees. Okay, we have to identify this figure as a line segment, or ray. We've done a lot with this. We should know now. If it has a point on one end and an arrow on the other, that is a ray. But if we were going to name it, it doesn't tell us we have to name it. If we were going to name it, we would need to write CD in all capital letters, because that's how we do this. And then put an arrow with one arrowhead over top. So it would be ray CD. 39 asks us if this is a right, acute, or obtuse triangle. Look at the angle that you can see. Plain as day, right here. Right angle. This is a right triangle. So number 40 is asking us about this heart, okay, and if it is symmetrical. Now, the one on your paper is a little bit more even than mine, and that's okay. But when we talk about symmetry, we talk about basically splitting something in half. And if you folded it together or you split it in half and laid the two parts on top of each other, they should look the same. Okay, if I put my heart this way, if I cut this heart in half, is that going to be symmetrical? No, because if I folded it over, these two little humps would be sticking out from the bottom instead. So that's not going to work. That is not a line of symmetry. Same thing here. This would not be a line of symmetry because if I folded this over, we would have one of our loops over on this side. But if I cut it straight down the middle and folded it on each side of itself, I would have a symmetrical figure. So yes, it is symmetrical. I hope that this review helped you. And if you have other questions, you can email me or have parents send a remind message. But you guys seem to be doing pretty well with your emails. So if that works best for you, then keep it up. Make sure that you get all your work done. Today's Friday. It's the end of the week. Week 2 is over. So that being said, make sure that you have everything in that packet done and have somebody send a picture of it to myself and Mr. B so that we can get you guys checked off that you got your stuff done this week, because we don't want you to get behind. So make sure you've got all those things taken care of, and I will see you next week. Bye.